Perfect. Thanks.
Go right ahead.
Great. Thank you, everyone, for joining this morning. My name is David Su. I'm in product marketing for Workload Automation, CA. And today's Tech Talk is our third in the series that we have. And today we'll be talking about getting started with our Workload Automation advanced integration for Hadoop on the DE platform. We have Justin Hubbard, who will give himself an introduction in a little bit. I just want a couple of housekeeping notes. If you have questions throughout the session, please input your questions on the Q&A box on the right, and we will get to them. And then at the end of the presentation, after Justin is done, I'll be back for a couple other short commercials and links to other resources, that sort of thing. So with that, again, thank you very much for joining. Justin, I will turn it over to you.
Thank you, Dave. Hello, everyone. My name is Justin Hubbard. I'm a member of the CA Workload Automation SWAT organization. And let's just dig right in and get started. We're going to go over a couple items before the demonstration. We're going to go into some big data challenges. What are the advantages of utilizing Hadoop Advanced Integration with your workload automation solution? We'll go into the Hadoop Advanced Integration implementation, and then we'll cover a workload automation DE demonstration. To start, what is the advantage of utilizing Hadoop Advanced Integration? Currently, you have two separate organizations within your business environment. You have your Hadoop organization and your workload organization. Through the use of Workload Automation DE, you're able to design complex workflows that integrate SAP, Oracle E-Business, PeopleSoft, your batch jobs, database jobs. You have a wide variety of options, and you're able to integrate those together using a wide variety of combinations. However, Hadoop is out of the mix until we've implemented Hadoop Advanced Integration. Now you're able to get end-to-end insight of your business workflows with Hadoop, combining your Hadoop batch as well as your external batch together for a complete overview of your workflow process. With Hadoop Advanced Integration, the implementation is pretty simple and probably very familiar to what you're doing now with the plugins. You would have your CA Workload Automation Scheduler, and you would, which in this case is Workload Automation DE. You would have a system agent installed on some remote system, and with Hadoop Advanced Integration installed, the Hadoop Advanced Integration is installed in a very similar fashion to a plugin. The Advanced Integration component, when a job is being executed, will open an SSH session to a specified edge node within your Hadoop cluster. The agent does not have to be installed on the edge node. It can be installed on a random remote machine as long as it has access to connect to the edge node specified. For Hadoop clusters, we currently support Cloudera and Hortonworks distributions, and the team is currently working on certifying IBM Big Insights and MapR. So with that, we'll get right into our demonstration of workload automation and advanced integration for Hadoop with dSeries. Just one moment as I share my screen. Len, are you able to see the screen?
You're good. We can see.
All right, excellent. So we can see here that I have opened the desktop client. I am running Workload Automation DE Release 12. In order to execute and utilize the Hadoop Advanced Integration and Hadoop Workflow, you need to be on Release 12 of Workload Automation DE or above. I have here a use case, which is a sales use case, taking advantage of all of our Hadoop job types. We can see the Hadoop job types have been added on the right-hand side. In this use case, we've got some sales data that is stored in a database, as well as business identifying data, which is stored in CSV files, which are on an edge node within our Hadoop cluster. Using our Scoop and HDFS jobs, which I'll go into details on in a moment, we will import this data into our Hadoop distributed file system. We'll then use a Oozie Workflow as well as a Pig script to perform some analytics on this data and group this data by business and total the number of sales that business had for this year, and then sort that data. We'll then create a Hive table within Hadoop in order to display that data to our users, as well as export the data to an external relational database. And then I have an additional Oozie Workflow and Hive Script specified, which is essentially just cleanup scripts that will allow for this demo to be executed on repeat. They're not part of our demonstration, but they work in the same fashion. We'll cover those as well as we go into detail. Before we actually go in and execute this workflow, I want to cover how we can set up our connections to our Hadoop Advanced Integration agent and how that agent connects to our edge nodes and our clusters. So I've just moved to the topology screen. We can see the standard topology view has now been updated to have agents and advanced integrations. And we can see I have an Hadoop Advanced Integration specified here. If we double click on the Hadoop Advanced Integration, we can see I've defined, just like I would any other agent, the host name, ports, my encryption key for the advanced integration. With Hadoop Advanced Integration, as I mentioned, the agent doesn't have to be on the edge node that you're going to be connecting to. It doesn't have to be defined on any system within the cluster that you're going to be connecting to. It will open a remote session to the cluster that we want to execute work against. We do this by specifying a connection profile. And a connection profile is a new concept for Hadoop Advanced Integration. Here we specify first we give our connection profile a name, which I've called cluster 1. We specify the host that we're connecting to and the port. And I'll cover the difference between this host and this name node host in a moment. We do specify our default bin directory for Hadoop on the edge node that we'll be connecting to. In this case, it's the default, so I have not specified it. Now, we can also optionally specify an address to an Oozie server. And JDBC connection strings for Hive if we're going to be executing Hive jobs with this connection profile, and Scoop if we're going to be connecting to an external relational database and executing Scoop workflow. However, notice these are not required. You do not have to define a connection profile with these. And this gives you a lot of flexibility because it allows you to find multiple connection profiles for different users who may need to execute Hadoop workflow on the same edge node within the same cluster, but you may not want user X having access to a Scoop to execute Scoop workflow. You may not want user Y able to access your Oozie server. Therefore, you're able to optionally add these to each connection profile. So we can see I actually have 3 connection profiles. If I look at the second one, I specified my Hive connection, but I did not specify Scoop. And if I look at my third one, I did not specify a Hive connection, and I did specify Scoop. So that's the big difference here. You can specify specific information for to connect to the same cluster using different connection profiles. Additionally, you'll notice that on my second 2 connection profiles, I've had this name node host fill in. Within a Hadoop cluster, there are several slave nodes and 1 name node, which is the master node. If you're going to be executing your workflow and connecting to the name node as your connection, you don't have to specify a name node here. If it's blank, it will know that this is both the name node and the edge node. But if you're going to be connecting to an edge node that's not the name node, you'll need to specify your edge node host as well as your name node host. Your edge node host will be the actual SSH connection that's open. Additionally, we have to specify some credential information to execute this workflow. So let's close out the connection profiles. Our first type of security profile defined, which stores our connection information, is our HDFS security profile. HDFS security profiles are used for all Hadoop job types. This will be the user that is actually used to open an SSH session with the edge node box. For our HDFS security profile, we would specify our connection user and password. but we can also specify a path to a key file as well as a passphrase. Or if we don't want to specify the path to the key file, we can store the key string within our security profile for that user and add the passphrase. The key string will be encrypted and stored within the DE database. In order to execute Hive Workflow, we have to provide the username and password for our executing user. So we have this Hive security profile, which, given a username and password, will allow for you to connect to the Hive database. And if we're going to be executing Scoop workflow against an external relational database, we have to specify the username and password for that external relational database. As we've seen from the connection profile I'll be using, I'll be connecting to a MySQL database. You have to specify the JDBC URL for that external relational database, and if necessary, the driver class for that JDBC driver. The external relational database JDBC drivers need to be pre-installed and placed within the Hadoop cluster in the Scoop home directory. So make sure that's done ahead of time, or else your Scoop jobs won't execute. So that will cover the definitions of connection profiles and security profiles. As I mentioned, you can restrict access to connection profiles and security profiles using the same security policies that you're used to. So if we go into our permissions for our user, we can create a permission on connection profile or security profile using the same regex type system that is already used for all of our other permission policies. So let's go ahead, and we've described our use case. I'll go ahead and trigger this application. And we'll just give it a moment to pick up the active application. There we go. And I'll go ahead and release it. Before I release it, I just want to make a note. This is a slightly wrong running application. So I'll release the application, and then I'm going to go into detail one-on-one on each of the job types and what they're doing for this use case. The workflow might get ahead of us, but the application will hold on this link. So we'll be able to see the actual results of what happened if the workflow does get ahead of my explanation. So I'll release the workflow. And we'll start with our first job type while this is executing, which is our HDFS job. Just a second. I'll actually go back and show it a little bit easier. With our HDFS job, the first thing we have to specify is our agent or our advanced integration. We have to specify the connection profile and the security profile that we're going to be using. For the Hadoop distributed file system job type, we provide 5 file operations that can be utilized and taken advantage of by the job type. We can create an empty file on the Hadoop distributed file system. We can make a directory on the Hadoop distributed file system. We can remove any file or directory on the Hadoop distributed file system that we have access to. And we can copy or move files or directories within HDFS. Additionally, with copy or move, we can copy from our local edge node up to HDFS. We can copy from HDFS down to our local edge node specified in our connection profile, or we can copy and move within HDFS. We can specify multiple file paths for files that we're going to be, in this case, copying, but if we're using other file operations, touching, for example, we can create multiple files using touch. We just have to specify our path, and we can additionally browse the edge node or the Hadoop distributed file system depending on the job type. So I'll go ahead and remove that. We specify the destination directory where we're going to be, in this case, since we're doing a copy from our local edge node of the CSV files up to the Hadoop distributed file system. I'm going to be storing them in my user directory within HDFS. And this last line here is our job status refresh. Our job status refresh is the amount of time in between the advanced integration opening an SSH session with the edge node to check on the status of the job. With Scoop, Scoop allows us to import or export from an external relational database. We have to specify our connection profile for our edge node as well as the HDFS security profile. And additionally, we have to specify our scoop security profile, which is going to be the user we're connecting to that external relational database as. We can choose to import or export from an individual table. In this case, I'm going to be importing a table called business, and I'll be storing the contents of that table at the user Hadoop business directory within HDFS. I'll be importing the following columns: ID, name, and parent, and only IDs that are greater than this value here. This is essentially the same syntax that you would be using for a SQL where clause. I don't have a boundary query being used here. A boundary query, so Scoop will import data from external relational databases in splits. It'll attempt to split the data into sections and import them all in parallel. The boundary query by default takes the minimum value and the maximum value of the primary key for that table and will then split that into quarters. If that works for your default, that's excellent. But in many cases, the primary keys may not be distributed evenly, in which case Scoop allows for you to define your own boundary query to allow for those splits to be more accurate and more even for your import. For importing null strings or non-string null values, you have the option to specify a symbolic string to represent that null when the data is imported into HDFS. Here I'm using the string UNDEF to represent that null value. So any nulls that are in my table, when we actually look at the CSV files, the result set will be represented by that undefed string. Any additional parameters for Scoop, Hive, or Pig can be defined on the command line, can be specified here and executed along with your Scoop job. I have an example of that a little bit later on in our demonstration. And once again, we have our job status refresh. One of our job types is the Oozie Workflow job type. The Oozie Workflow job type allows for predefined Oozie workflows to be executed from Hadoop, from our Workload Automation DE product. So maybe your Hadoop end users have a workflow that's very complex and they don't want to break it out into applications on Workload Automation DE, or perhaps there's additional functionality such as MapReduce programs or Spark programs that Oozie script is executing, and you want to be able to control that from Workload Automation DE. You have that capability. You just have to specify the path to the properties file on your edge node in order to execute that workflow. For Pig, we give you the ability to execute Pig scripts. You have to specify, once again, your Hadoop connection profile and your HDFS security profile. You specify the path on the edge node to the Pig script that you want to execute. Additionally, if you're using parameter files or property files as part of the Pig API, you can specify your path to your param file and your property file. In my Pig script, my param file is just specifying the paths within HDFS that the results of my Scoop and HDFS jobs and MapReduce workflow are stored. The property is just setting the logging to verbose. Like I said, we can additionally add additional parameters. I'm doing that a little later on in my last Scoop job, which I'll show in a moment. My Pig and my MapReduce jobs are performing the analytics. This is what's actually grouping the sales data together and totaling the total number of sales per year for my businesses. If we look at our Scoop export job, this is now doing the export option from taking my HDFS result set and exporting that into a table specified by my Hadoop connection profile. I'm exporting to a sales table. The source for my data set is in the retail demo directory in HDFS. This is where the results of that Pig script were stored. I'm not using a staging table, though one can be specified here. I've specified my null string interpretation values. And we can see that I'm using this additional parameter here, update key ID. What this is doing is instead of having Scoop automatically attempt to append the data to the table, it's telling Scoop to perform an update on the key that I specify, and that's the column ID. Lastly, once again, we have our job status refresh, which is 5 seconds for this demonstration. The default, by the way, if I didn't mention it, is 60 seconds. So we've got through the bulk of our use case. Let's go back to our monitor and see how we're doing. So it would appear that I ran into an issue. This is actually, so we can go through, I'm not going to debug this, but I will show anytime there is an issue, we will get a spool file that indicates the command that we're building. For all of our different applications, we can go ahead and retrieve the spool, and which will actually contain the log output for the actual job, so we can see the results that were actually outputted as part of my pig script. We can see here with our Hive script, this was meant to create a table partition within my Hadoop distributed file system. I'm going to share now a view from Cloudera Hue. And we can actually see, if I go to my Hadoop user, this is where HDFS, we can see the imported CSV files. The import from Scoop, which succeeded, was stored in our business directory. By default, since I didn't specify any additional parameters for that Scoop, it would attempt to split 4 ways. So we see our 4 splits here with our data set. And we can see the results of the pig and Oozie workflow are stored in the retail demo folder. And we can see them stored here in this file. My Hive script created a Hive table from this result set. So let's take a look at what it created. And we can see that we actually have our table created in Hive. So going back to DE, just for the purposes of time, I'll complete the failed job so that we can continue forward. And I'll release my held link. And this will allow my cleanup Oozie script, which cleans up all the files and directories I created, and my Hive script, which removes the table that I created, to execute. However, in the meantime, I'm going to return to the PowerPoint and allow us to continue on. Len, we can see the PowerPoint now, correct?
You're good.
Okay. So we'll get to questions in a minute. We did have a couple announcements that Dave wanted me to get through. To start, all the customers I'm assuming are Workload Automation DE customers. We are beginning development on release 12 SP1. If you would like to sign up to participate in sprint reviews and to participate in the validation of pre-releases of SP1, you can sign up at the link here, validate.ca.com. For resources on Hadoop Advanced Integration, you can go to the product page link as well as the DocOps documentation link here. For additional Tech Talks, to access to the Tech Talk events as part of our Tech Talk series, our landing page is at the link listed here. And for office hours for Workload Automation DE, our next live chat event is actually this Thursday, March 10th, and the event is 2495. You should see it on the calendar within the communities. Dave, I'll let you talk a little bit more about this. We do have a return on investment event for CA Workload Automation that is next week, March 15th.
Thank you, Justin. So, yeah, this is just a plug for an upcoming webinar. If you are interested in seeing some of the quantitative results of migrating off of a open source or homegrown solution to Workload Automation, we will have not only Forrester, but also a customer talk through a use case of how they did it and some of the benefits that they achieved by doing so. And this webinar is coming up next Tuesday, I guess a week from today, March 15th at 11 a.m. And of course, we'll have a replay available for that as well. I want to just also say that if there are any questions, please input them into the Q&A section of the webinar, and we'll hold just a couple minutes and give people a chance to enter anything in.
While they are loading in their questions, my contact information is here. justin.hubbard@ca.com. You can feel free to reach out to me anytime with questions for Workload Automation, DE, or Hadoop Advanced Integration. Additionally, as I mentioned, we do have several community events links that were posted earlier. If you're not on the community, I highly recommend becoming active in the community, and you can ask us any questions there, and any number of our Workload Automation DE staff should be able to assist.
All right, any questions? All right, well, I think that's it. So one last thing, in 2 weeks, so we have our Forrester webinar next week, March 15th. In 2 weeks, if you go to the Tech Talk landing page, which Justin mentioned, we will have our next Tech Talk, which is on tips and tricks for workload automation ESP. So if you're a mainframe customer that has DE as well, you can join that and pick up some information. So I do see a question coming in. Justin, do you see it?
Yes. Is there any timeout for SSH connections? There is the ability to configure the timeout. I don't know the default timeout off the top of my head, but Sucheta, I'll follow up and I'll comment on the event actually with that information. However, the time between opening SSH sessions by Hadoop Advanced Integration by default is 60 seconds, but as we saw, you can define that within the job definition.
Great. Any other questions? All right. Well, thank you, Justin. Thank you, Len and Chris, for hosting. And thank you, everyone, for joining. Have a good day.
Thank you.